classification of pressure measurement, as I have told. So this is the general classification of the pressure measurement. That how or what are the different types. I have uh, uh, tried my level best to quote all type of pressure measuring sensors and transducer in this particular pressure measurement classification by using different components, by using different components or that sensor or transducers that are commonly used for the measurement of pressure. So functionally, it has been classified into two parts. One is mechanical type of pressure measurement, and another one is electromechanical type of pressure measurement. I have already in the discussion of the first slide, I have told you that it can be bifurcated or it is bifurcated into three different parts. That is a high pressure measurement, low pressure measurement, then medium pressure measurement, and all these equipments or all these sensors or transducers are not commonly used for the measurement of low, high, or medium type of pressure. But in this particular case, few of them are used for the measurement of a pressure for low pressure, some are used for moderate pressure, and some are used for the high pressure measurement. So the general classification has been highlighted or reflected in front of you, which is classified into two categories, that is mechanical type of pressure measurement and electromechanical type of pressure measurement. Prior going for electromechanical type of pressure measurement, we will thoroughly try to discuss with mechanical type of pressure measurement. Then we people will switch over to the electromechanical type of pressure measurement. It is also further subclassified into various types. So first of all, we will try to cover a point mechanical type of pressure measurement. In mechanical type of pressure measurement, it is classified into two parts. One is the static and another one is the dynamic. We have seen the static pressure and we have seen the dynamic pressure. So static pressure is nothing but don't depend upon the motion, whereas the dynamic pressure measurement is it depends upon the motion of the fluid or liquid. This is the major difference between static and dynamic. Then under this one, what type of component are reflected or executing that execution for standstill type of pressure measurement and dynamic type of pressure measurement. So in dynamic, force summing devices are used, and in static type of transducer, manometer, U-tube manometer, well type manometer, inclined manometer. So in a static type of pressure measuring devices, we people are commonly using manometers, and these manometers are further classified as U-type manometer, well type manometer, and inclined type of manometer. So these lower one are the subparts of manometers. So all are manometers, and this works based upon the variation in the difference of the liquid level. Variation in the difference between the liquid level. Now, how we are measuring? If I want to briefly specify this one, that I am interested to measure the pressure. However, we people are using the liquid as a medium to measure that particular pressure. So what happens? One U-tube manometer, if suppose we people are having U-tube manometer, in that particular U-tube manometer, if I have filled a liquid and hold it at a particular condition that matching the tube level, what we are going to do is that when pressure is not applied at any one of the end, of the U-tube, at that time the level will be similar, and the difference between the height which we people are measuring and depend upon the applied pressure, that we people are not getting because pressure is not applied to the manometer. Then at the second instant, whatever the unknown pressure which we are interested to measure, in that case, we are applying the unknown pressure which we are interested to measure, and at one end, there are two ends. At one end, we are applying unknown pressure which is to be measured, and at the another end, it is exposed to the atmospheric pressure. So here, when you are applying, and when your pressure, unknown pressure is greater than that of atmospheric pressure, definitely your liquid will try to move in the downward side. Your liquid will try to move in the downward side. So there will be change in the height depending upon the pressure that has been, unknown pressure applied on the U-tube or applied for the U-tube. There will be change in the height of the liquid. So you can measure that height we people are having. I have already given the formula also. P is equal to rho gh. So G, gravity, we people are acceleration due to gravity we are having. Which type of liquid that has been used, you can put the value for the density of that particular liquid, whether you are using water, it's having one density, or whether you are using this one, mercury, it is something 13 point something is the value. So these are the densities that we people are having, or the acceleration due to gravity, that value we people are having. So you can easily determine the pressure. And the another mean is also there, pressure measurement depending upon the differential pressure, that you are having the known pressure and unknown pressure we have applied. So you can easily determine the delta P. Delta P is the change in the pressure. Delta P is equal to P1, which is applied at one of the leg, and delta P2 is applied at the another leg. So P1 may be known or P2 may be known. So delta P can be easily determined depending upon the differential pressure value we are getting. So suppose P1 is known, delta P we have obtained. So you can determine what is P2. Okay. So static is bifurcated for manometers only, and dynamic, that is force summing. So diaphragm type, it is further classified as a diaphragm type, bellow type, and Bourdon tube type. Okay, so diaphragm type is further classified as flat, corrugated, and capsule type, whereas Bourdon tube is calibrated or is classified further as C-type, helical type, spiral type. And bellows are, you can use, bellows are having a single shape. Now what is the structure? Structure for your Bourdon tube, I will not go in the depth of the flat. As in upcoming lectures, we will go in the depth for this one. So this is the structure which we people are having for the Bourdon. Okay, for the diaphragm, sorry, for the diaphragm. Structure is simple. These two are the fixed one. Here we people are having the diaphragm. When we are applying a pressure, suppose P1, I have noted it with a P1, definitely this will move in the downward direction. This will move in the downward direction. Only shape and this one has been changed in the diaphragm type for flat, corrugated, and this type. Okay, so either you are applying force from this side, or either you can apply it from P1 and P2. Which one is the greater in that direction? This is going to deflect. Okay. So this is diaphragm. Different type we will see in the upcoming lectures. Bellows. How we people are utilizing the bellow? Bellow structure is also a simpler one. This is the structure of the bellow. Okay. And this structure is connected to some of the mean. So this can be used as a primary transducer, and it can be connected to even your LVDT also. So LVDT can work as a secondary transducer. As we are applying a pressure at an input, at that time, this bellow will elongate. This bellow will elongate and it will try to create a motion in the forward or reverse direction depending upon the applied input, whether your pressure is high or whether your pressure is low. So it is going to elongate or means motion will be there for this particular bellow tube. So it will generate the output. That output is calibrated in terms of pressure, because the input which we are applying is the pressure, and depending upon the pressure which we have applied, that much elongation or enlargement of the bellow will take place. So it is totally depend upon the applied pressure. Third one is the Bourdon tube, which is further classified as C-type Bourdon tube, then helical or spiral type of Bourdon tube. And in this one, the general structure of the Bourdon tube is very simple one. So here, C-type I will draw. Okay. So C-type Bourdon tube. In this one, what happened? A C-type structure is there, and this C-type structure, actually we people are applying a pressure over here, and this is connected via some mechanism, via pinion and all these actuators. This has been connected to the pointer, and here is the scale. In the next lecture, I will show that particular strain C-type gauge also. When we are applying a pressure, pressure will move through this one. And what is going to happen, as you increase the pressure, this tip will try to move in the upward direction. In the upward means this is going to become straighter. Likewise, it may try to move in the upward direction. So pointer will move according to the applied pressure. So there are C-type, helical type, spiral type. Its shape is going to change, and that change in the shape is going to reflect. That change in the shape is going to reflect on the resultant output of the pressure, and it is calibrated directly in terms of pressure. The best example to understand this one, you have seen the different type of pressure gauges that are mounted on some of the control system components. They are pressure gauges, and in that pressure gauges, actually Bourdon tube type of construction is used. So I will show actually what is that Bourdon tube, and you people will be easily get the concept of Bourdon tube. As in the next lecture, we people are going to start with the detailing of the Bourdon tube. This is the classification that is related to your dynamic force semi devices. So if you see diaphragm, bellow, Bourdon tube, as per the definition of the dynamic, these all are generating motions. These all are generating motion. Diaphragm motion, bellow enlargement, then Bourdon tube change in the shape. So these are the inputs that is depend upon the motion. Whereas in manometer, here is the actual thing at the primary level. Though it is at the still condition, but when you are applying a force, it is going to remain same. It is going to remain same. So here that is called as a static one. And so this is mechanical type of pressure measurement, whereas electromechanical type of pressure measurement, in electromechanical type of pressure measurement, this can be commonly used. This can be commonly used for higher pressure measurement also. That is nothing but potentiometer, photoelectric, capacitive, piezoelectric, then inductive type. Now the question in your mind will be that how this electromechanical type, for example, potentiometer, we people are using for the pressure measurement. I don't know how many of you have heard about spirometer, that is commonly used device in medical system so as to record the respiration rate. So in that one, they people are using a potentiometer type of a sensor to reflect the resultant output of the Rest